Ever wonder what actually happens before a chip gets made? I mean, when you hear about a new iPhone chip or an AI superchip, it just sort of appears, right? But here's the thing, before that sliver of silicon ever sees a factory floor, a bunch of engineers have already spent years drawing its blueprint. And that phase, the chip design phase, is where the magic really starts. So, let's talk about what that blueprint looks like. It's not like drawing a house, where you sketch walls and doors. Chip design is more like writing an impossibly complex recipe that billions of tiny switches, called transistors, will follow. The first step is called logic design and architecture. This is where engineers decide what the chip will actually do. Will it be a brain for your phone, crunching photos and videos? Or a specialist for a data center, handling AI training? The architects sketch out the big picture layout. How many cores, how much memory, what kind of connections? They're basically writing the table of contents for the chips. Datasheet. Now, how do they even do that? Here's where the tools come in. Engineers don't sit around with graph paper and colored pencils. They use something called EDA software, that stands for Electronic Design Automation. Think of EDA as the ultimate digital workshop. It's a suite of programs that lets engineers design, test, and simulate a chip entirely on a computer before a single piece of silicon is made. They can run billions of operations virtually, check for errors, and optimize for speed or power, all without ever touching a machine. It's like building a skyscraper in a video game before you pour any concrete. But here's the kicker, most companies don't design a chip from scratch. It would take too long and cost too much. Instead, they license pieces of the blueprint from other companies. And that's where two names you'll hear all the time come in, ARM and Synopsys. Let's start with ARM. You've probably seen ARM based in a tech spec. ARM is a UK-based company that designs the core architecture, the fundamental blueprint, for the central processing units, or CPUs, inside nearly every smartphone and many laptops. Apple's M-series chips? Those are ARM-based. So are Qualcomm chips, and most Android processors. ARM doesn't make the chips itself. It just sells the design. It's like a world-class architect who draws the perfect house plan. And then other companies buy that plan and customize the kitchen or the windows. Then there's Synopsys. Synopsys makes the tools and the building blocks, what the industry calls IP cores. These are pre-designed components, like a memory controller, a USB port interface, or an AI accelerator, that engineers can drop into their chip design like Lego bricks. Synopsys also makes the EDA software I mentioned earlier. So when a company like NVIDIA designs a new GPU, it uses Synopsys tools and might use Synopsys IP for certain parts. They are the unsung heroes behind the scenes. Now here's a common misconception. People think chip design is all about coding. And sure, there is a lot of code. Engineers use special hardware description languages like Verilog to describe how the chip behaves. But it's more like writing a legal contract for every single electrical signal. Every wire, every clock tick, every power connection has to be defined precisely. And unlike software, you can't just send a patch later. Once the chip is etched into silicon, those billions of transistors are frozen in place. You get one shot to get it right. So, why should you care? Because the design phase is where the value is created. The foundry, the factory that actually makes the chips, is a commodity. Anyone can pay TSMC to print their design. But the design itself? That's the secret sauce. That's why Apple's chips are so power efficient. Or why NVIDIA's AI chips are so fast. It's all in the blueprint. And here's what's interesting. The cost of designing a cutting-edge chip has skyrocketed. For the latest 3nm chips, design costs can reach hundreds of millions of dollars. That's why you see consolidation in the industry, only the biggest players can afford it. And that's also why companies like ARM and Synopsys have become so valuable. They provide the shortcuts that let everyone else compete. Next time, we'll get into the next step, how those designs actually get printed onto silicon, a process called photolithography. It's like developing a photo, but with lasers and liquid chemicals and precision down to the width of a few atoms. Subscribe to Taiwan Tech Pulse for more Taiwan Tech 101.